Hello everyone, my name is Mark and welcome to my channel. I've been playing Kerbal Space Program for a few years now and have always been intrigued with the mathematics being used to model it. You see, I'm very fond of mathematics and I'm very excited any chance I can find it actually being used. Yes, I'm a big geek, nerd, whatever you want to call me. But in this video, I will model an orbit of Kerbin with some basic conic section mathematics. Full disclosure though first, I am by no means a rocket scientist. There is another YouTuber by the name of Scott Manley that I strongly encourage you to visit. I will leave his channel link in the description below and in the video above. In fact, it's one of his videos on Kerbal Space Program that inspired me to investigate the mathematics behind it. So Scott, if you're watching this, thanks for the push, and let's get to it. Now, this is just a quick introduction, and I will not be going step by step through all the calculations. I figured I would spare you that at least. But if that is something you are interested in, let me know in the comments below, and I will gladly oblige. In Kerbal Space Program, you can achieve a nearly perfect circular orbit of Kerbin, just as you could see a perfect circle or circular cross-section if you intersect a plane with a cone parallel to its base. But most of the time, you'll have an elliptical orbit similar in shape to a cross-section of a plane with a cone not parallel to its base, just like the one shown here. Here is a mock-up of an elliptical orbit around Kerbin. An important note to mention is that the planet now is acting as one of the two focus points being used to create this particular ellipse. This orbit is being modeled by the standard form of the equation given above, and this should give us exactly 100 kilometers for a periapsis, which is the closest distance the ship should get to the planet during any point of its orbit. Now, the developers of this program also tell us that Kerbin has exactly a 600 kilometer radius, which leaves us with 900 kilometers from the center of Kerbin to the center of this particular ellipse. If all goes well, when we put this into the program, we should have achieved exactly a 1900 kilometer apoapsis, which is the furthest distance that the ship should get at any point during its orbit around Kerbin. Now, I am going to change things up a little bit because this truly isn't in standard form. We're going to change the denominators. We're going to take the square root of them and then square them so you can truly see the values that are being used to generate this particular ellipse. So instead, we're going to replace them with the equivalent forms of 1600 squared and 500 radical 7 squared. And there's our center. So by doing the equation in this format, we clearly now see the distance from the center of the ellipse to the periapsis to the apoapsis. It's clearly 1600, which you see in the denominator of the first fraction of the equation, and it also clearly shows us the distance from the center of the ellipse to the end of its semi-minor axis, which in this case winds up being exactly 500 radical 7. Now, if you consider the denominators of this particular equation as is, and then you square them out and find their difference, take the difference and take the square root of it, you're going to get the value that represents the distance from the center to either foci of this particular ellipse. In this case, that value is 900. Now, 900 is what we saw before because that was the leftover from the center of Kerbin to the center of this ellipse, and things seem to be working out just fine. Now, if you take 1600 and you divide it into 900, you're going to get the value of 0.5625, which represents the eccentricity of this particular ellipse. Now, the eccentricity is essentially a value between 0 and 1, and it represents, let's say, the circular nature of the ellipse. The closer to 0, the more round the ellipse. The closer to 1, the more elongated the ellipse. And if you have an eccentricity of exactly 0, you actually have a circle. You no longer have an ellipse. And anything beyond 1 is going to give you hyperbola. Okay, now this is very important. If you're going to play around with any of the saved game files, what I recommend you do is either back them up so that you don't corrupt any of the files that you're currently working with, anything you really worked hard to put together. Or I just started a whole new game, to be honest with you, so everything's starting fresh. And so what we're going to do now is we're going to go into the vehicle assembly building. New file, new game. Jebediah should be available to help us out. He's always good for these missions. And let's go ahead and build ourselves a very, very simple rocket. I'll just start with the Mark 1 command pod. Let's put on a parachute. just to make it look like we're being serious about putting somebody in outer space. Let's take a very, very simple tank of the right size. There we go. And let's max out how many fins we can put on this thing. And let's choose those, and let's go. There we go. And it actually looks more like a missile, but who cares? It's going to go in outer space for testing purposes anyway. Now you're going to want to title this ship to something that you're going to easily remember. I'm going to call this thing Orb 1. Okay, and once you save it, you're going to be able to find it in your save files much easier. So let me go ahead and save that right now, and we're going to put this out to launch. Okay, before we actually put it into orbit according to the equation that we created before, I'm going to put this in a perfect circular orbit of Kerbin of 100 kilometers or 100,000 meters. I figured we'd do that first just so you get a feel for how you edit the save files if you haven't done that before. So before we do that though, we have to hit F5. We need to do a quick save of this because that's the file we're actually going to change. So make sure you quick save it. Now the important thing is you need to find out where Kerbal Space is installed, and once you find out where the game is installed, you double click on that on Kerbal Space, and you're looking for a file that says saves, because that's where all your games and quick saves and stuff are going to be saved. So I'm going to double click on that, find the name of the file, what you called the game when you started it. I called it that. And now you see that there are 4 files here because I started a brand new file here, so there's not going to be much in this. Persistent is like your main file. Your quick save is right here. Ignore the load metadata. We're going to go after quick save, the one we just hit F5 for right here. So I'm going to double click on that, and it's going to open up in Notepad. This is standard for Microsoft Office, I believe. Whatever kind of easy document editor you want to use, I'm sure it's fine. Just make sure it's the same format. So here we are. Now I got to find the ship. We called it Orb 1. So I'm going to go to Edit, and you're going to use, under Edit, you're going to use the tool Find, or you can hit Control F if you know the hotkeys. And we're going to look for Orb 1. I already have that typed in. So when I hit Find Next, it's going to go all the way down, and it's going to automatically find exactly Orb 1, which is the name of the ship. So we got to start changing some of the configuration here. So first of all, sit. It's at pre-launch. We need it to be orbiting. Obviously, it's not going to be landed, so we have to change true to false. And let's see, keep going down. Launched from, that's okay, but landed at, we obviously don't want to be landing, so we're just going to delete that. And everything else should be fine. We're not splashed down, everything else looks good. But then what we're going to do is we're going to scroll down to where we see the orbit. These are the numbers that are essentially dictating how this ship is orbiting, right? So if we look at basically all these numbers here, but we're only going to play around with 2 of them. We're going to play around with the semi-major axis and the eccentricity, which are the first 2. Inclination gives you how you're orbiting. If you want to be, you know, like kind of off the equatorial orbit, we're not going to mess with that either. And all the other ones have to do with it. The interesting one also is this. We're not going to mess with this reference equals 1. The number 1 refers to Kerbin. I don't know all the numbers. You could look that one up for each planet. You can actually kind of cheat and put whatever ship you want in an orbit around any planet you want doing this. I don't like playing that way. This is only for testing purposes. And again, if you're going to do this, make sure you back everything up, okay? So what I say, we're going to do a perfect circular orbit. So I'm going to change the eccentricity to, like I said, 0. And I need to change the semi-major axis. So if I want a 100 kilometer orbit around Kerbin, okay, I need to take 600 kilometers and add 100 to it, so it's 700 kilometers or 700,000 meters. Okay, so I'm going to change that, and now this should be good. Don't forget to hit save. I'm going to minimize that because we don't have to close it out every single time as long as we've saved it, and I'll get rid of that. And now we can actually test our orbit. So seeing that it's a quick save and I just edited it, you're just going to have to hit F9 and hold it. And that's going to essentially launch our last quick save. And boom, we are in outer space. Let's hope we don't crash. And there we are. Let's go around a little bit. There we go. There we are above Kerbin, right? Lovely. You can actually see we're directly above it. It really put us directly above Kerbin. So if I hit, you can either hit M to look at the actual orbit, or if you come down here and you go to, let's see here, map. Oops. Well, that's what we want. Well, let's look at the map. Look, if I put my cursor over it, it's exactly 100,000 meters. And the periapsis is also 100,000 meters, which means we have a perfect circular orbit around Kerbin. Now, you can do this if you're good at manipulating your controls and whatnot, you can achieve this. It's not that big a deal. You shouldn't have to cheat to create a circular orbit. Anything close to the same periapsis and apoapsis is fine. If we come down here, though, let's see. If we come down here and we look, we should be able to also see the periapsis and the apoapsis down in this window as well. So you can either be in the map view, or you can be looking at that little panel bottom left hand corner. So there we are. Okay, so let's change the orbit of this. Let's test our equation. Okay, so to test it, we need to bring back our, where's our file here? I have it. I did not close it out, I promise. There it is, our quick save. We don't have to save it again. Now, we wanted an eccentricity of, what was it again? It was 0.5625 is what I calculated. So I'm going to come here to eccentricity, and I'm going to go 0.5625. There it is. And again, since this is the semi-major axis, what we're going to do is we're actually going to take the number that gives me the biggest distance from the center to its orbit, and we're going to take the actual number from the equation, which, if you recall, was 1600. Okay, so that's 1600 kilometers, but we need that to be in meters. So we're going to move the decimal over 3 more places, because unfortunately the format here is all in meters, not in kilometers. And let's go ahead and hit save, and let's see if our equation worked. So get to your game, hit F9. Hopefully we don't crash. There we are. Okay, now for fun, let's not look at the bottom panel. Let's look at the actual orbit here. Let's see if this worked. And there's our orbit of Kerbin. Let's see if I can focus this a little better. There we go. And let's take a look at the periapsis. Look at that. Perfect 100,000 meter or 100 kilometer orbit around Kerbin. And our apoapsis is exactly 1,900 or 1,900,000 meters, I should say, from the center of Kerbin. So Kerbin is acting as a focus, or one of the foci. I've been doing a little reading. The other foci that's used in creating this ellipse is kind of not tangible in this situation. It's kind of an interesting concept. I'm going to be doing a little bit more reading on that, but this is pretty much how you can change your orbit. And if you are interested in any of the details, the calculations, or if there's anything else you think you might be interested in and you want me to go ahead and do a little research on, I'll be glad to do it. If you found anything wrong with this, or if there's any suggestions you have, please feel free to leave them in the comments. But I had a lot of fun, and I always have fun playing around with math, and now we can see it actually in play for at least rocket science in Kerbal Space Program. I am not a rocket scientist, therefore I don't know if this is exactly what happens in outer space, but I'd like to think that this is a pretty good simulation. They say it is, but pretty much that's it for now. I appreciate your patience. Thank you very much. And again, if you need any questions answered, or you have any comments, concerns, or suggestions, please feel free to leave them in the comments below. Hit that like button and subscribe if you'd like to. Otherwise, I'm just going to say goodbye for now. So this is Mark signing off. Take care.